We have another example on the board. This time we have fraction at the left side of the equal sign and on the right side of the equal sign. Someone is going to ask from which side we're supposed to start. You can start from the either one. I'm going to start from the left side. Let me copy down. I have cotangent x minus 1 over cotangent of x plus 1. Next, I'm going to use the reciprocal relation. I'm going to rewrite cotangent as 1 over tangent of x minus, because I have fraction over here and I have whole number over here. I'm going to convert this whole number to fraction. I'm doing everything step by step. 1 over 1, because 1 over 1 is equal to 1. Over. Again, I'm going to use the reciprocal relation, and I'm going to write, again, 1 over tangent of x plus, again, I have 1, because I have fraction, I'm going to rewrite this one as fraction, 1 over 1. Okay, again, I'm doing everything step by step. Now, I have two fractions. I'm supposed to subtract them. I have to find a common denominator. Common denominator for these two fractions is tangent x. I'm going to copy down first fraction, because this one has already tangent x, minus tangent x, because common denominator for both of them is tangent x. And if I have tangent x in the denominator, I'm supposed to have also tangent x in the numerator. Over. We have 1 over tangent x plus, again I have fraction, common denominator is tangent x. Okay, I simply multiply 1 by tangent of x, and whatever I did in the denominator I have to do also in the numerator, so 1 times tangent x gives me again tangent x. Next, let's rewrite these fractions like this. 1 minus tangent x over the common denominator, which is tangent x, over, and I have 1 plus tangent x over tangent x. And now please notice that we have division of two fractions. Now, in order to divide fractions, we're supposed to copy down the first fraction down. I have 1 minus tangent x over tangent x. And remember, the fraction bar represents division. So anytime we divide fractions, we have to convert the division to multiplication. That's why I'm going to write multiply, open parentheses, and I have to multiply by the reciprocal of the second fraction. That's why I have tangent x over 1 plus tangent x. 1 plus tangent x. Because I have multiplication, this tangent and this tangent will cancel out. Next, I'm supposed to perform the multiplication, and I'm going to end up with 1 minus tangent of x over 1 plus tangent of x. Please notice that we get exactly the same expression like we had on the right side of the original equation. So means that we prove that the left side is equal to the right side. Let's take a look at this example. Again, we have fraction on the right side of the equal sign and on the left side. Again, you're supposed to start from the either side. I'm going to start from the left side. Let me copy down the left side. I have 1 minus cosine x over sine x. And someone is going to ask what we're supposed to do next. We have the simplest forms of the trigonometric functions because we have just sines and cosines, and what we're supposed to do next. What I would do, I would multiply this fraction by 1. 1 in terms of the conjugate of the numerator. Simply multiply by 1 plus cosine of x over 1 plus cosine of x. 1 plus cosine of x over 1 plus cosine of x is equal 1. 1 times the original expression is original expression, right? So we didn't change the value of the original fraction by multiplying everything by 1. Now let's take a look at what we have next. Okay, I'm going to multiply numerator by numerator and denominator by the denominator. But look carefully at the content of these two parentheses. Are you seeing something? This is nothing else, just the difference of two squares. What I mean by that? I have formula which says a square minus b square is equal a minus b, a plus b. Okay, you're supposed to remember this formula very well. And what we're supposed to do next? This is my a and this is my b. This is my a and this is my b. I'm going to rewrite this as 1 square minus cosine square x over, and I have to multiply denominators. I have sine of x times 1 plus cosine of x equals. Now, what we have in the numerator, this is 1 minus cosine square x. You're supposed to remember the Pythagorean relation, which says sine square x plus cosine square x is equal 1. Okay? You're supposed to remember this. Now, if I'm going to move cosine to the right side of this equation, I'm going to have sine square x equals 1 minus cosine square x. So instead of 1 minus cosine square x in the numerator, I'm going to simply write sine square x. Why I'm doing that? Let me show you. I have sine square x over sine x 1 plus cosine x. Square and sine x will cancel out. See, I have to eliminate this sine of x. And let's take a look what I'm going to end up with. I have sine of x over 1 plus cosine of x. Now, let's take a look what we have got so far with the right side of the original equation. As you can see, these two expressions are identical. So what we can say? We simply prove that the left side of my equation is equal to the right side.